Hi children, good morning. So today we are going to solve the problems from exercise 10.1. So it is exercise 10.1. In the previous video we have learned the formulae related to mensuration. So now we'll try to solve the problems from exercise 1.1 in a very quick way as we know the formulas. So here the first question, it is given as a joker cap is in the form of a right circular cone. So it is in which form? It is in a right circular cone. So here is the right circular cone, right? So as it is a right circular cone, it is our right circular cone, it is a joker cap, and the radius is given as 7 centimeter, and the height of the cone, it is given as 24 centimeter. And he asked to find the area of the sheet required to make that cap. So here area of the cap we need to find. What is given actually here? A joker cap with base radius equal to 7 centimeter and height is equal to 24 centimeter. Height equal to 24 centimeter. Now sheet required to make a cap, it is nothing but area of cap, or we can call it as curved surface area of cap. So it is nothing but area of cap, it is equal to CSA, curved surface area of right circular cone. So what is the formula now? CSA of cone, it is pi r L square units. So we know the value of r, we know the value of h. So what we are now supposed to find, we don't know the value of L. So first find out the value of L. L is equal to, we know the formula, that it is equal to square root of L is equal to square root of r square plus h square. It is square root of r value is 7 square and it is 24 square, and it is nothing but square root of 25 square. If you do it, then we get it as 25 centimeter. Now area of cap is equal to pi r L, that is 22 by 7. We know that the value of pi is 22 by 7, and r value is given as 7 and L value we got it as 25. So 7 get cancels, so we get it as 22 into 25, and it is equal to, it is 550 centimeter square. But the requirement is we need to find area of the sheet required to make 10 such caps. So area of the sheet required to, area of the sheet required to make 10 such caps is equal to 10 into area of cap, that is 10 into 550, that is equal to 5500 centimeter square. This is all about the first problem. Now let me move to the next question. So the second question, a sports company has ordered to prepare 100 paper cylinders for packing shuttlecocks. So here we need to take the cylinder. So here this is our second question. Shuttlecocks are packed in this, and the height of the cylinder is given as 35 centimeter, that is the length or height they have given it as 35 centimeter. It is 35 centimeter, and the radius is given as 7 centimeter. So radius R is given as 7 centimeter. Now he asked to find the paper sheet required to make 100 such cylinders. So when we are speaking about the packing, so even the bottom is packed, even the top is also packed, not only bottom, top also packed. So it will be total surface area of the cylinder we need to find. I hope it is clear to all. Fine. Now here, what is that? A cylinder packing is done for shuttlecocks is, so height of the length or height of the cylinder is given as 35 centimeter. Base radius is given as 7 centimeter. So now, so area of cylindrical packing is nothing but total surface area TSA of cylinder. We know that the formula for that one is 2 pi r into r plus h. So when it is 2 into pi value, we know that it is 22 by 7 into r value is 7, and 7 plus h value is 35. So 7 get cancelled. So it is 2 into 22 is 44 into 42. So here 2 4s are 8, and 2 4s are 8, 8 plus 16, that is 24, 4 2 carry, 4 4 16, 17 18, 1848 centimeter square. But he asked to find the area of the paper sheet required. So here this is for one cylinder. So area of the sheet required, area of the sheet required for one cylinder, it is equal to 1848 centimeter square. Now we need to find the area of the sheet required for 100 such cylinders. So area of the sheet required to find 100 such cylinders is equal to 100 into area of cylinder, that is 100 into 1848, that is equal to 184800 centimeter square. Next, so let me add the page. Now the third question, so find the volume of a right circular cone. So here again it is given as cone, so it is given as a cone. Now, so what is given actually? Volume of a cone we need to find, and radius is given as 6 centimeter and height is given as 7 centimeter. So height is given as 7 centimeter, radius is given as 6 centimeter. So we need to find the volume. So here it is given a right circular cone whose base radius is r, it is given as 6 centimeter. Height of the cone, height h, it is given as 7 centimeter. Now he asked to find the volume. So volume of a cone, it is equal to 1/3 pi r square h cubic units. So this is 1/3 into 22/7 into r value is 6 into 6 into h value is 7. So here 7 get cancels, here 3 1s are 3 2s are, that is equal to 22 into 12. So 12 2s are 24, 4 2 borrowed, 12 2s are 24, 25 26 264 cubic centimeter. This is the third problem. Now fourth problem, look at the fourth question. Here they have given that curved surface area of a cylinder, it is equal to curved surface area of a cone. So CSA of cylinder, it is equal to CSA of cone. So next what they have given, that the radii of their bases are same, radii of their bases. So radii of their bases are same. Okay, first let me write the formula. Curved surface area of cylinder, that is 2 pi, as it is r1, and let us take it as h, because we don't have h in this curved surface area of cone. You take it as h. The h is nothing but that is this. Next it is curved surface area of cone, pi r2 l. As their radii are equal, radii are same, so r1 is equal to r2. R1 is equal to R2. Now he asked to find the ratio of height of cylinder to the slant height of the cone. So ratio of height of cylinder to slant height of cone. So that means we need to find the value of h by L equal to how much. So take this equation down, easily we can finish it off. So here 2 pi r1 h, it is equal to pi r2 L. We need L here, so bring this L, transpose this L to the other side. So when it is transposed to the other side, it will become 2 pi r1 h by L is equal to pi r2. Now transpose this, all this term to the other side. So here h by L, it is equal to pi r2 by 2 pi r1. So pi get cancels. We know that r1 is equal to r2, so even r1 r2 will get cancelled. Here it will be 1 by 2. So therefore h by L, it is equal to 1 by 2. I hope it is clear to all. Fine. So what is the ratio? Ratio of height of a cylinder to slant height of a cone is 1 by 2. Now let us see the other question. So the other question is, a self-help group wants to manufacture a joker cap. So all are behind the joker cap. So even we will take the joker cap. And this is question number 5. So they want, so the radius is 3 centimeter and height is 4 centimeter. Actually height is given as 4 centimeter, radius is given as 3 centimeter. So we know R and H, right? Now he asked to find if the available paper sheet is 1000 centimeter square, now how many caps can be manufactured? So here the total sheet available with them is 1000 centimeter square. Now we need to find how many caps can we get it from that. So for that, here joker cap, let us write whatever that they have given, a joker cap with base radius or it is equal to 3 centimeter and height is given as 4 centimeter. So area of the cap, it is equal to curved surface area of cone. That is nothing but it is, so area of cap is equal to pi r L square units. So pi value, we will take it as 22 by 7. R value is 3 centimeter. L value we don't know, so we need to find the value of L. L is equal to, we know that it is equal to R square plus H square, that is R value is 3 square plus 4 square, it is equal to square root of 5 square, 5 centimeter. So substitute in this, so it will be 22 by 7 into 3 into 5. So it will be 3 5s are 15, 15 2s are 30, 0 3 carry, 15 2s are 30, that is 330 by 7 centimeter square. Now total sheet available, so sheet available is 1000 centimeter square. Now number of caps, it is equal to sheet available by area of a cap. So sheet available is 1000 by area of cap is 330 by, sorry, what is 330 by 7. So it will be like 1000 into 7 by 330, 0 get cancels. Here it is 100 into 7 by 33. 33 ones are 33, 33 threes are 99. Keep the decimal. So one reminder, it will be, if you keep the decimal, we have one, it will be 10. 10 it will not go, so add one more 0, it is again 100, 3. So it will be approximately, that is 21.21. So how many number of caps we can get? Number of caps we can get for number of caps we can get for 1000 centimeter square is 21. This is how, this is all about fifth. Now let us see sixth question. So sixth question, a cylinder and a cone have bases of equal radii and are of equal heights. So a cylinder and a cone, they are of equal height and equal radii. Show that their volumes are in the ratio of 3:1. So this is all about, it is question number 6. Radius of, first thing they have given radius of cylinder is equal to radius of cone. Here that is R1 will be equal to R2. Their heights also equal. Height of cylinder, it is equal to height of cone. So H1 it is equal to H2. Now volume, he asked you to find the volume of cylinder by volume of cone. So volume of cylinder is nothing but pi R1 square H1, and this is 1 by 3 pi R2 square H2. So if you see this pi, R1 and R2 are equal, these two will get cancelled, H1, H2 will get cancelled. So it will be almost all equal to 1 by 3rd, and due to the reciprocality it will multiply it like 3 by 1, it is equal to 3 by 1. So therefore ratio of their volumes is 3:1. This is all about sixth question. Now seventh question, question number 7, it is given as the shape of a solid iron cylinder, and it is height 11 centimeter, base diameter is 7 centimeter. Find the total volume for 15 such rods. Here rods are in the shape of a cylinder. So rods are in the shape of a cylinder. This is all about 7th question. Here the height of the cylinder is here as solid iron is in the shape a solid iron rod. Is in the shape of cylinder. So height is given as 11 centimeter and diameter is given as 7 centimeter. Diameter is given as 7 centimeter. Now he asked to find, try to find out the volume of a cylinder. So here volume of a iron rod is equal to volume of a cylinder. So it is volume of iron rod, it is equal to volume of cylinder is pi r square h. Here diameter we know, so h we know, so r value will become d by 2, that is 7 by 2 centimeter. So substitute in this, that is 22 by 7 into r value is 7 by 2 into 7 by 2 into h value is 11. Here 7 get cancels and 2 ones are 2 11s are. So 11 into 11 it is 121 into 7 by 2 and it is equal to 7 ones are 7, 7 twos are 14, 4 1 carry, it is 847 by 2 centimeter cube. It is cubic units. Now this is all about the volume of a rod. Now volume of 50 iron rods, that is equal to 50 into 847 by 2, so 2 ones are 2 25s are, so it is equal to 25 into 847, that is 4 2s are 8, 4 1s are 4, 4 1s are 4, remainder is 3 and it is 75, it is centimeter cube. This is all about problem number 7. Next we will discuss about the problem number 8. So question number 8. Now let us see. A heap of a iron rice is in the form of a cone whose diameter is 6 meter and height is 8 meter. He asked to find its volume and the canvas cloth required to cover it. So it is a cone again. So it is a cone. Here he gave that a heap of rice is in the form of cone. So diameter is given as 12 meter, height is equal to 8 meter. So simply height they have given, so height is 8 meter, diameter it is given, not, so diameter it is equal to 12 meter. So if D is 12, then R will be 6 meter. Okay, first he asked to find the volume of the heap, volume of heap of rice. It is nothing but it is volume of cone. So volume of rice, so volume of heap of rice, it is equal to 1 by 3 pi r square h, and it is 1 by 3 into, but here the value of pi he asked to take it as 3.14. So let us take 3.14. R value is 6, so 6 square into h is 8. So that is 1 by 3 into 3.14 into 6 into 6 into 8. So 3 ones are 3 twos are, that is 2 6 are 12, 12 8s are 96. So 3.14 into 96. So 3.14 into 96. So here it is 96 into 3.14, it will be almost all equal to 301.44 meter cube or cubic meters. This is the volume of the heap. Now he asked to find the canvas required, the canvas required to make, or to cover, better to say to cover, the heap. It is nothing but curved surface area of cone. So area of canvas is equal to pi r L. Again here we don't know the value of L. So first find out the value of L. L is equal to square root of r square plus h square, that is square root of r square. R square value is 6 square plus 8 square, it is nothing but 10 square, it is 10 meter. Now substitute in this, that is pi value is 3.14, r value is 6 into 10. So 6 into 4, 6 4s are 24, 4 2 carry, 6 1s are 6, 7 8, and 3 6 3s are 18, 18.84 into 10, it is equal to 188.4 meter square or square meter. So area of canvas required to cover the heap, area of canvas required to cover the heap is 188.4 meter square. And last problem from this, ninth question, question number 9. Here he asked to the curved surface area of cone. Already they have given curved surface area of cone. It is pi r L square units, and it is given as what CSA of cone is given as 4070 centimeter square. Now the diameter, base diameter is given as, base diameter is 70 centimeter. So what will be the radius? So radius is equal to 70 by 2. Better you write it as 72 by 2 for the easy calculation. That is 72 by centimeter. Now he asked to find the slant height. Slant height is equal to question mark. So pi r l, it is given as 4070 centimeter square. Pi value is 22 by 7 and r value is 70 by 2 into L, it is equal to 4070. So 7 ones are 7 tens are 2 ones are 2 11s are. So it is 11 into 10 is 110 into L is equal to 4070. So L is equal to 4070 by 110. So 0 0 get cancelled. It will become 407 by 11 and it is 37 centimeter. 11 ones are 11 threes are 33, 7 is the remainder 7. So slant height of cone is 37 centimeter. Right, children? By this we have finished our first exercise. Thank you everyone. Have a nice day. Take care.